Okay, I think we're going to kick things off. Hi, everybody. Thanks for joining me. My name is Josh. I am a developer advocate at Attendees. We do managed services and hosting for ClickHouse, which is a really, really fast SQL compatible database. We're not going to talk about that in this talk. So if you want to hear more about that, please come find me afterwards and we can talk more about that. For this talk, we're going to be talking about OpenTelemetry and specifically how we can use it to debug our applications. So this talk is going to kind of focus on an application point of view, an app developer's point of view. And then after this, you'll get to hear more about sort of the platform and infrastructure side from the fine folks from Red Hat. So let's dive in, if this works. All right, we're just going to use the mouse. Okay, so does everyone recognize this vacuum tube computer, right? This is a vacuum tube computer. Everyone remember, does everyone know the story of like the first actual computer bug that was actually a bug? Like, but the term bug predates that, right? But Grace Hopper had a bug that was actually a bug that you could see through these glass vacuum tubes, right? Like that's visibility, observability. That's what we're talking about today, okay? Oh, and this is working now. So really, while I'm talking, this is the question I want you to have in your head is how do we debug our applications? How do we know why they're breaking, what's wrong, how do we fix them? That's what we're talking about. It's like this, right? Like everybody knows this is how we debug our applications. We just Google it, right? This is what all senior engineers do is we're just Google machines. I hate that meme because if you're actually a senior engineer, you know that once you get to this point, your job is mostly done. You have done all of the hard work. This is the easy part, right? Like this is where like I have to deal with 17 different programming languages. I don't know the nuances of all of them. I have to look it up sometimes. But getting to that error message, right? Getting to what I needed to Google, that's where all the work is. That's where all of the investigation happens. And that's where we need some tools to help us out. So realistically, how do we debug our applications at scale? For me in a production system, right, looking a few years ago, it's a lot of reading. It's just reading logs. It's reading through, looking for a specific identifier or looking for specific correlations or trying to, I need 4 different monitors and I can kind of see all of the different things and correlate, oh, this is happening over here. It kind of looks like it corresponds with this spike over here. Let me find the log messages for that plot. It's reading. We need a better way. So we'll get to that. But first, I want to say logs kind of get a bad rap in observability today, right? Like people say, oh, logging, you don't need it. You should do distributed tracing. You should do metrics. Logs are just expensive. It's a bunch of data volume that you need to deal with. I think they kind of get a bad rap that's not fair because if we look at this typical, right, like if we just look at this really, really simple request log, this is, I'm sure we've all seen this exact request log, right? Like maybe in JSON or something, but I'm just putting it here so we can see it like this. This has so much information that we actually need about the operation of our system if we can aggregate it and start to do, right, like some kind of analysis on this. It is missing one important thing, right? Like let's add duration. That's a really important thing. So, okay, let's enrich our logs. Let's make sure we add the duration of the request. And then all of a sudden, we can build this, right? We have our RED, or request errors duration metrics, our golden signals, as Google calls them, where you bring in also the resource utilization of the underlying infrastructure. So we could build this entire dashboard just from counting the things that are happening inside those request log messages. It's a really, really powerful little bundle of data. But if we go back to our log, it's still missing some context, right? Like this is just kind of some data points that don't have a lot of context to tie it back to what else is happening within our system or what the user might have been trying to do in this moment. So we can contextualize it, right? And this is an idea that probably is not new to most of you. Back in like 2015, I was on an engineering team and we had a message queue system, right? And we had this brilliant idea at the time. Let's just put our request ID on every message that gets passed through the entire system so that we have a user-centric understanding when there's an error message. We know exactly what user action was the root cause or that triggered that particular error, right? So we're starting to look at this from a user-centric point of view, but we still have a disconnect because we then just have this sea of things. This is all the stuff that happened as part of that request. No ordering, no structure, no logic, no understanding of the system topology. We can do better than this. And the way that we do better than this is with distributed tracing. And if we think about what a distributed trace is, at the end of the day, it's really just a really well-structured log message that has a parent ID. And in OpenTelemetry, we call these the trace ID and the span ID and the parent ID, right? So a distributed trace, when we're going to talk about this, and it's going to, maybe it seems complicated. It's not. It's just this. It's just a tree structure of request logs, right? And that lets us do some really cool things. It lets us build this kind of waterfall graph that you're probably used to seeing in tools like Jaeger, or maybe you've seen like similar graphs in like your Chrome developer tools, right? This is very immediately obviously useful for certain things like understanding the flow of the request, for things like seeing where the latency might be happening, right? If we can imagine that the horizontal axis is the duration. And we got this just from embedding those parent IDs, right? But there's so much more to this than just what we see here, right? We can take this data structure and actually do so much to understand our system with this. So I'm going to talk about distributed tracing a lot, and I love it. Observability is not any one signal, right? Like we need all of them working together. Metrics are great because they're numbers which establish patterns. We can do math with them, and then we can see when things don't align with the pattern that we expect. So metrics are really great for answering the question, is something wrong? Traces tell us where the thing went wrong, right? That's what they're going to help us do, is zero in on that problem. These days, it's actually not where is the problem, but like who is the team that owns the thing where the problem is occurring, right? And so tracing, especially if you're doing really good annotation of your trace metadata, of your service metadata, right? Like you can zero in immediately. No investigative work, right? It's already there. In the first alert that you receive, here is the exact root cause, service, and the team that you need to reach out to in response to this incident. And then all of that is eventually going to lead us back to, right? Like eventually we're going to have a log message, we're going to have an error message that tells us what the actual problem was. So we still need the logs. So at the end of the day, observability is not any one of these things. It's not any specific tool, and it's not any complicated mechanical engineering definition that you may have heard. It's a really simple thing. Can I understand what I'm looking at? Can I see what my system is doing and understand why it's doing what it's doing? So it's a simple question, but answering it is challenging. We need to be able to answer these types of questions, right? What did the user experience when they were interacting with my application? What code or configuration do I own or does my team own that was part of that experience? What was the state of the resources, the infrastructure handling that request, right? Where was it running? And what else within the system could have contributed, right? We're not dealing with single tenant systems, so we need to know when there's a bad neighbor or when there's resource contention that might be causing our application to behave in unexpected ways. And to me, distributed tracing is really the killer app when it comes to answering these kinds of application level questions. It's not going to be that useful on your infrastructure, but for your applications, it really is invaluable for answering those questions, right? Because as we looked at, we can understand the complete request flow through our entire system. From that, we can actually create a real-time map of the system topology and all of the dependencies so that we can see, right, like how our system is architected without having to design that graph up front. We showed, right, how we can derive metrics from the richness of the trace metadata. We can get RED metrics, but we can also do more, right? Traces have unlimited cardinality, so we can throw any business metrics that we want onto those traces as metadata, like say the order value of a transaction or the amount of resources used to process a specific request, right? Like all of these things, we can just embed this as trace metadata and then derive metrics from that. That's really, really powerful at scale. And those log messages that we really need to find out why our shit is broken, excuse me, we can make them so much easier to find by enriching them, by attaching them to a specific trace, right? Then we know exactly the log message that we need, and we don't need to worry about the millions of other in syslog that we don't need. So, kind of talked about this at a philosophical level. We're going to now talk about like how do we actually do this? What are the tools available to us? OpenTelemetry, for those not familiar, has been around since about 2019. It was formed from two different projects merging. So everyone's familiar with that XKCD strip of like we have 13 formats, now we have 14 formats. OpenTelemetry is actually a success case of reducing the total number of formats. It's amazing. So it's really cool, and we're unifying observability, right? And I said observability is not any one of those three signals, right? Metrics, traces, and logs. OpenTelemetry very much is about the signals. It's about the tools to deal with the signals. And so it has tools for metrics, traces, and logs. More signals are coming later this year. Profiling, events, and exceptions are very exciting, and the community is working on those. But for now, this is what you can work with OpenTelemetry. This is sort of the state of the SDKs, and it is evolving very, very fast, right? Like you can see that tracing is very mature in OpenTelemetry, and this has happened over the course of the last, I would say, 2 to 3 years. Metrics and logging are maturing very, very rapidly, and metrics is very quickly starting to displace Prometheus as the de facto standard. There was no de facto standard before for tracing, so it just has established itself. And then logging is a little bit behind metrics, but I would say it's coming into its own. If you're currently using something like Promtail or Fluent, maybe stick with it for a little while, but start looking at this. So what is OpenTelemetry? This is a great question that we got at the beginning of this talk, right? Like, okay, I've heard about this OpenTelemetry thing. Is it a format? Is it a technology? Is it a tool? Like, what is it? It's all of those things, right? So it's specifications. Oops. These are the heart of the project, right? This is necessary for the rest of the project to exist. So we have specifications that say how things should work, right? Then we have the libraries and tools that implement those specifications. And most importantly, it's an open source project. It's the community that creates those tools and that uses them and contributes to them. So the specifications, right? W3C trace context. This is one of the most important specifications to OpenTelemetry. This is the specification that says how we propagate those trace IDs, those parent IDs that we were talking about at the beginning. Those are so important. That's the specification for that. So we have a specification for how we can put those in our HTTP headers, and then any web server, anything that follows that specification can propagate it to downstream services, and we get that trace ID through our entire system. That thing that my team had to do all that work on our own to do in 2015. We get the language APIs. So these are the actual APIs, the functions that we can call from within our applications to generate telemetry. So you can call a function that says, hey, I need a trace span. I need some metrics. I have some metadata that I want you to attach to the current span, etc. Right? And then we have OTLP. So this is the OpenTelemetry format. This is not to be confused with OLTP, right? Which is a database technology or architecture. OTLP is a format that can be represented in protobuf or in JSON, and it is used to efficiently transmit OpenTelemetry signals over the network. It's the semantic conventions. These are huge. Naming is one of the hardest things in computer science. Naming things consistently is one of the biggest challenges in observability. Like, even if it's just the difference between like casing or underscores, or if you put a dot, or if you put the unit type on your Prometheus metrics, right? Like, these things seem simple, but when you dig into them are annoyingly complicated. So the semantic conventions, if we follow them, give us a consistent naming scheme that we can use across our entire ecosystem of tools and technologies. Then we get the tools and stuff to implement this, right? So the SDK, technically a specification too, right? But we're not being pedantic. The SDK is the implementation that you're going to run alongside your code, right? Inside your runtime of whatever programming language you're using. And it's going to actually, take those API calls from the API and generate telemetry using whatever processors and exporters you've configured. We'll talk about that in a little bit. OpenTelemetry is very extensible. It's the instrumentation libraries. So these are the things that understand what the web frameworks that you're using are doing and turn them into observability signals. So say you're using Express.js. There's an instrumentation library available for Express that knows, okay, this is an HTTP request. I need to generate a trace span for it. And it will call the OpenTelemetry API and do that based on whatever's happening inside Express. There is the collector. This is a really big component that we're going to talk about more in a few slides. But essentially, this is your alternative to like a vendor's observability agent. It's going to go onto your node, and it's going to receive all of the telemetry coming from that node and then forward it to the backend. And it can also do some processing and normalization and filtering and sampling and all of those cool things. It's the Kubernetes operator. So this is great if you're running in Kubernetes because it can auto-instrument your services and it can deploy the collector for you and configure it for you. So definitely use that if you're running on Kubernetes. And then it's the community, right? This project is sponsored by the CNCF. It is the second most popular project by contributions under the CNCF after Kubernetes. It's events and meetups like this one. Thank you for coming. And it's the OpenTelemetry end user working group and all of the other working groups and SIGs, right? We're at the Open Infra Foundation, so you're familiar with the SIGs here. just like that in the CNCF, we have various SIGs. For end users of OpenTelemetry, I think that the end user working group is a really interesting place to start because you can hear stories from other end users about how they're using OpenTelemetry in practice, in production today. So let's talk about the stack a little bit. Typically, to do observability, right, we're going to have some stuff that we have to deploy in our code, in our services, and then we're going to have a pipeline that we need to maintain somewhere in OpenTelemetry. That's going to be the OpenTelemetry collector. If you're working with a vendor, you might be using OpenTelemetry in conjunction with their vendor agent instead of the collector, or you might be using a mix of both. And then finally, you need some kind of backend where you can put all of the data, store it, query it, alert on it, actually do useful things with it. We're not going to talk too much about that today, but I do have a talk at Open Source Observability Day next week. It's free if you want to hear more about that. So in your code, oh, this slide got messed up. Oh, well. In your code, that's where the language API and SDK goes. That's where you have processors and exporters, right? So I mentioned that it's an extensible architecture. So we have plugins that we can use. We have instrumentation libraries, right? Those are the things that translate. And then we have manual instrumentation. This is important too, right? Those instrumentation libraries, they understand things like HTTP requests and database calls and ORMs, but they don't understand your business and what's important to your business and your users. So manual instrumentation, whether you're completely generating the trace or just adding some metadata to the trace that you got from the instrumentation libraries, is a really important step to really grow into your OpenTelemetry setup and customize it for your business. Then we have the OpenTelemetry collector, right? I say on your node because typically I'm talking to Kubernetes audiences and they want to run this as a daemon set. And the asterisk is there because you might not necessarily run it as a daemon set, but typically you're going to have an OpenTelemetry collector, at least one per host, and then you might have a deployment of collectors somewhere else that's acting as sort of a gateway to your backend storage. The collector supports receivers, processors, and exporters. These are the plugins for the collector. These are way more exciting than the ones that go in the SDK. There are over 90 of them, and this is what means that the OpenTelemetry collector can translate between essentially any telemetry formats in existence today, right? If you have something exporting in Datadog format and you want to put that into Loki or Thanos, right? Like wherever you want to go from anything that's compatible on either side of OpenTelemetry, it can translate. And then finally, you need to put all of that stuff somewhere, right? Like Prometheus, Grafana, Jaeger, OpenSearch, ClickHouse, talk to me, or Datadog is probably the most popular vendor, right? Oh, and I missed some slides. Right, host metrics and logs. Those come from the collector. You're going to hear more about that in the talk after this one. And automatic instrumentation, that also happens on the node, right? Like if you want to run some no-code instrumentation that injects itself into whatever is running on your cluster, that's where the automatic instrumentation goes. Be the operator. Okay, so let's talk about the stack a little bit. We kind of mentioned all of these components, but just this is like a way to visualize where they all go. If you want to like take a picture of this slide or grab it from the slide later, right? So you can kind of see a lot of stuff goes inside your code, inside the OpenTelemetry components, and then the collector is mostly configured via YAML. We'll show that in a little bit. Okay, so how do I actually use this? It's pretty straightforward. I instrument my application using the instrumentation libraries and whatever auto instrumentation is available. If I have additional business context to add, I add it, right? And then I deploy a collector, and the collector points to whatever backend I'm using, or multiple backends if that's the case. So the code to do this is pretty straightforward. All of these examples come from the OpenTelemetry demo project, which is available on GitHub, and I'll share the link. But it's a great project that has an example of a real-life OpenTelemetry instrumentation in all of the 11 different programming languages that are supported by OpenTelemetry. There's no example for Swift because that's kind of complicated, but if you have a use case for backend Swift, the project would love to hear from you. Yeah, so here's what it looks like in Node.js, right? We have a few dependencies. It's pretty straightforward. Now, OpenTelemetry is kind of like a bag of toys more than a batteries included pre-built solution. So yeah, we do have 5 different libraries that we have to include here, and there's a little bit of configuration for each one of these. So this is kind of where like some of the challenges in OpenTelemetry is that the ergonomics are not quite there yet because the underlying pieces are still being actively developed. But I have faith that as the kind of underlying SDK stabilize, people will put effort into making the ergonomics much better, and it'll be more competitive with what you could get from a vendor. And then manual instrumentation. This part's really easy, right? Like every programming language that supports OpenTelemetry, there's going to be some function or some method that you call to get the current context, and then you can add stuff to the current context. Pretty straightforward. And then we have the OpenTelemetry collector. So that's where we gather and forward our telemetry. We apply filtering, sampling, and batching rules. I said all of this. Translate between compatible sources and destinations. Gather node and cluster level telemetry, right? And the configuration is just YAML. So we just say, hey, I have some receivers. This is the configuration for my receiver, right? There was a question earlier about Prometheus. So yes, the OpenTelemetry collector, amongst its 90 receivers, which can they can be pull or push based, right? So they can reach out and make requests like a Prometheus scraper would, or they can provide an endpoint and you can push to them like you would with InfluxDB or Prometheus Remote Write or a number of other technologies. OTLP would be the common one. And then you put it all into a pipeline and you're done. Everything is awesome. Kind of. I think we can actually take a little, like 5 more minutes from the other talk. Yeah. 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 I want to make sure I can answer everyone's questions because I think it'll be relevant for the next talk.
Hey, so you said one of the backends, like the biggest vendor would be Datadog.
Yes.
If you're going to use Datadog as your backend, do you need to include from a little bit of place of ignorance? Do you have to include APM in your Datadog subscription and everything for that, or is just like straight Datadog with log ingestion and then being able to build dashboards off those metrics coming in?
I don't know specifically for Datadog. What my experience has been with the various vendors is that they have varying degrees of integration with OpenTelemetry, right? All of them will tell you that they support OpenTelemetry. Sometimes that means that they just put it in like a separate bucket, separate from the rest of your telemetry, and you can look at it, but it's in its own bucket and it's not integrated with their other tools well. Other vendors are going to be more integrated, where like whatever kind of AI assistance tools, right, or like root cause analysis, it's going to be comprehensive across all of the data, but that's rarer. Any other questions? Don't be shy. It's okay. All right. Well, connect with me if you'd like. There's a blog post with a great deep dive on the OpenTelemetry collector if you'd like to hear more about that. And thank you so much.